All right, so the whole point of what we've been reviewing this year has been topic 2 in IB, which is mechanics. And just to be clear on what we mean by mechanics, we're talking about motion, forces, energy, impulse, momentum, and more to the point, I want to talk about sort of just the big picture, which is we're talking about how things move and how do we get them to move or stop moving or change direction. That has been the whole point of everything we've been reviewing for the past 3.5 weeks. So again, we're looking at things like velocity, acceleration, position, time. That's the description of motion. And then when we talk about forces, momentum, impulse, free body diagrams, and today energy, we're talking about, well, okay, well, how did I get the thing moving in the first place? Or if it was moving, how did I get it to change direction? How did I stop it? And what I want to do before you do the reading is give you a brief overview of what it's going to look like as you do the reading. So the big topic is energy, energy conservation, work, and power. That's not how the IB states it, but that's really what I want to cover. So basically, for our purposes, energy is a number that doesn't change in a process and is stored in a system in many ways. And this fact can actually help us solve physics problems. Okay? So this is the really quick summary of what you're going to get to in the reading. First, one way to store energy is in motion. And the formula for moving energy, it's written with an E and a K, and that's 1/2 mv squared. And this is called kinetic energy. A second way to store it, you can store it as gravitational potential energy. And that basically says you can store this number by taking a mass, giving it some height in a gravitational field. And there's a third way, and you know what, I'll actually draw like a little picture here. So imagine a box moving with speed v, mass m. Here, imagine you have like a little hill, and then here's a little object. It's got mass m, it's got a height h, and g, of course, points downwards. And the third way to store energy is what we call elastic potential energy. The formula is elastic potential energy. You'll also see it written as ES for spring, and that's 1/2 kx squared. This is the weirder one because imagine here I've got a spring, and then when I compress it, it's compressed a distance x. That's the compression. And k is what we call the spring constant. That's how loose or stiff the spring is. and it basically tells you how easy it is to stretch or compress the spring. X is how much you stretch or compress the spring. And what we're basically saying is this energy is stored in the spring by stretching it or compressing it. And the units of energy are joules, and that's written with the letter J. And if you want to break that into the fundamental units, that's going to be kilograms, meters squared, seconds squared to the -2. Okay, so for our purposes, what we're basically saying is there's this thing called energy, and this is how you calculate it for the object in question. So the whole point of this little part here that I'm showing you in this video is what is energy? Not how do we use it, simply how do we get it? Okay. Now, the next thing I want to talk about is a little bit of how we use energy in problems, and I'm going to use the idea of work, okay, and energy. So the whole point of using energy is when objects speed up, slow down, or change direction, when objects speed up, slow down, or change direction, the energy they store changes form. And work is the process by which energy changes form. So what we're basically saying is when I have a box, and you know I'm going to give you the formula for work first. So the formula for work is the process by which energy changes form through forces. And here's what I mean by that sentence. So work is basically how forces change energy from one form to another. In fact, I like that way of saying it better. Okay, so I'll say it like this. Work is how forces change energy from one form to another. And the result is that objects speed up, slow down, or speed up or slow down. So the formula for work is if I have a force and I move an object from here to here using that force over a distance d, you take the force, you times it by the distance you move the object through, and you times it by the cosine of the angle between the force and this displacement, or this distance d. Now, often the IB will write this as F times S times the cosine of the angle. So this is basically the definition of work. Now, here's how forces actually do the process of changing energy from one form to another. This is, again, a summary of the theory, and we'll actually apply this in class next time. Okay. And this is called the work kinetic energy theorem. Basically, when we have an object, and let's say this is the angle it moves through. Let's say it has an initial speed of 0, and then we drag it, and now let's say that it's moving here. What we're basically saying is that this force does work to give this object kinetic energy. So now there's kinetic energy stored in the object, and so what we're basically saying is that the work done on this object forces it to change kinetic energy. You'll also see this written as work is change in EK. And the full formula is Fs cosine theta is 1/2 mv squared minus 1/2 mu squared. And basically what we're saying is that you do work on the object to change its kinetic energy, to either get it moving or to stop it. And then the last big idea I want to talk about in this video is the notion of power. Power is measured in watts, which is joules per second. If you want that in the fundamental unit, that's going to be kilograms meters squared times seconds to the -3. And it's basically the work done divided by the time. Okay. And then efficiency is something you'll get to in the reading. We'll talk about that a little bit in class. But when you're trying to do, when you actually have like an engine that's running or a car that's moving, you'll put power into a system, and then you'll get some kind of power out of the system. But that's something we can get to a little bit in class. So this is kind of the theory part of energy. And again, I'm just going to have you read a little bit of this theory part, and I'll be posting a couple of example questions to sort of bring this to light in the next video.